So, all right, guys, so we're back from the usual interruption with the Zoom. So as I was saying early on, when we are solving equations of this nature, where we have the x variable on both sides of the equation, the first thing we want to do is to bring all the variables or all the unknowns that we are solving for by themselves. We're grouping them on one side. So in this case, we bring all the x's to the left-hand side, and we'll bring all the numbers to the right-hand side. So we do the calculation on the left-hand side, we subtract, bearing in mind that we are changing the sign to their opposite when we're moving these terms across the equal sign. All right, so we solve on the left-hand side, we subtract 5 from 7, 5x from 7x, we end up with 2x. On the right-hand side, we subtract 3 from 17, we end up with 14. Now we are left with 2x equal to 14, so we need to get rid of that 2 from the left-hand side, but we have to divide both sides by 2. So when we divide the left-hand side by 2, we are left with x. On the right side, when we divide by 2, we get 14 divided by 2, so that will give us 7, so therefore x equal to 7. All right, so everybody should be pretty much understanding what is happening here. Any question about this before I actually move to the next slide? All right, so I'll take your silence to be that there is no question. All right, here now we have the unknown that we are solving for in brackets. Now, when you're removing brackets, when you have this scenario, you can actually do it one out of 2 ways, right? You could treat the bracket like an unknown. So you are getting rid of the 2, so you'd have to divide both sides by 2. And so when you divide the left-hand side by 2, you would only have 3x plus 7 left on the remaining on the left-hand side. And then on the right-hand side, divide 16 by 2, you get 8. So you'd have 3x equal to 8. So that's one way to approach it. Now, suppose you are not that astute in doing it like that. You may want to remove the brackets, meaning that you use the distributive law, multiply what is inside by what is outside distributively. So you would get 2 times 3x give you 6x, and then 2 times 7 give you 14. And then now you bring the 14, we bring it to the right-hand side. And so we'll get 6x equal to 16 minus 14. And so once we divide, when we subtract 14 from 16, we get 2, and then we divide both sides by 6. So x would be equal to 2 over 6. And if we simplify that into a fraction, simpler fraction, we get 1/3. All right. Now, if we take the other approach, so just to note, if we take the other approach, you would still get the same answer. So if we take the other approach, meaning that we're treating the brackets like an unknown. So whatever beside the bracket, we're going to consider that it is multiplying the entire bracket. And so we have to divide both sides by whatever multiplying the brackets to get rid of that number. So here we would have 3x plus 7 is equal to 8. But now we will just move this 7 to the right-hand side. And so we will get 3x equal to 8 minus 7. And so that would leave us with 1 on the right-hand side. And now we need to get rid of a 3 from the side x. So we divide both sides by 3. So this cancel, let's be cancel on the left, leaving x. So we see that x would be equal to 1/3, which we would arrive at the same answer, but just a different approach. This one over here, we would have multiplied out the bracket, then solved. This one on the right-hand side, we would have gotten rid of the 2 by dividing both sides by 2. And then what remained from in terms of the expression, we solve that after we get rid of the 2 on both sides. All right, so any question about that? Is that clear to everybody? So whichever approach you take, you will get the same answer. So the preference is just based on what you consider to be easier to work with for you. And I would suggest that you use the method to solve that you find easy. You don't have to use the method that somebody else used. Just choose a method that you're comfortable with and work with that method. Once you arrive at the solution, you'll get your answer, you'll get your marks. All right, so moving on. Here we have now equations where we have fractions involving. Now, sometimes solving these can be a little bit confusing for students, but one of the key things to do when we are solving equations where we have fractions is really to get rid of the denominators first. That's an easy approach. I mean, you could take different ways to solve it, just as how we solved the previous one in 2 different ways. We could solve this with a number of different ways. But I'm going to just show you if we solve this working with the denominators. So I'm going to show you 2 different approaches to this question, and then for yourself, you will decide which method would pretty much work easier for you. All right, so what we could do on the left-hand side, we could just look at these 2 fractions on the left-hand side, and we could find the LCM of both. So adding the 2 fractions on the left-hand side, we would need to find the LCM. And so the LCM would be, for 4 and 5 would be 20. And so if we apply the general rule that we know about fractions when we're adding fractions. So here we would say, what we do to 4 to get 20, we would times 4 by 5. So we times the numerator by 5. So 5 times x down here will get 5x. And then now we say, what do we do to 5 to get 20? So we times the 5 by 4. So it means that the numerator we have to multiply by 4. All right, another way to look at that. So we'd have 3 times 4 will give you 12. All right, another way generally you can say 4 into 20 goes 5. So you take the 5 times the numerator, so you get 5x. Or you could say 5 into 20 goes 4. So you take 4 times the numerator, you get 4 3s 12. All right, so that would be on the left-hand side of the equation. But now on the right-hand side of the equation, we see that this whole number can take a denominator of 1. So the LCM here would be 2. So we can say 2 into itself goes 1. And so 1 times 3x will give you back 3x. And then now 1 into 2 goes 2 times. So we say 2 times the numerator, which is 2 times 2 will give you 4. And so we would have this situation here now. Now, once, if we do this now, what we would have to do to solve this is a method of what we call cross multiplying. So the denominator on the right-hand side, we cross it and use it to multiply the numerator on the left-hand side. So we call that cross multiplication, right? It's just a technique that we use when we want to get rid of the denominator. So this denominator on the left-hand side, we take it and cross it and multiply the numerator on the right. So bringing up the 20, we use it to multiply that expression in the numerator on the right and bring up the 2 on the left. So it means that what we have in the numerators are expressions. So remember now, keep your expressions in brackets. So for the left side, you would have 2 times and you keep the expression in brackets. So you'd have 5x plus 12. And on the right-hand side, we would take now 20 times the expression, which is 3x minus 4. All right, so the next step now is to remove the brackets by multiplying out what is inside. Use distributive law. So 2 times 5x gives you 10x. 2 times 12 gives you 24. And then now you would have 3 times 20 will give you 60. And so this becomes 60x. Sometimes this thing wants to do its own thing. All right, so we have 60x. And now 20 times negative 4 will give you negative 80. All right. And now we can follow the same principle that we have been following. Bring all the x's to one side. So we would have 10x on the left. Now we are bringing this 60x to the left. So we are going to subtract it. And now we're going to take the 24 and bring it to the right. And that's also going to be subtracted. So we would now have negative 80 on the left, on the right, minus 24. All right, now here on the left side, we see that the 60x numerically is larger, but in terms of the sign, we are going to take the numerically smaller one, which is 10, from the numerically larger one and keep the sign of the larger one. So 10 from 60 give us 50. And so we keep the sign of the 60. So we get 50x. Now on the right-hand side, you would subtract, both of these are subtracting, so you add them and keep the sign of subtracting. So you would have 104, so that becomes negative 104. And so next what we would do is to divide both sides by negative 50. And so this right-hand side, you cancel out the 50 and you leave with the x. There, that should be the left-hand side. And so the right-hand side now, you can cancel. The numerator would give you 52. Remember the sign going to cancel out because negative divided by negative gives you positive. So 2 into 104 will give you 52. So the numerator will be 52. And 2 into 50 would be 25. Now that would give you your answer for x. Now, when we look at this approach, it requires you to do a number of things. Yes, Ms. Wilson, go ahead.
Sir, is it that you just choose to use 2? Because I don't see where that 2 is coming from. I was thinking that you're going to divide it by the 50 and get a mixed fraction. I don't know.
All right, now if we divide it by 50, we would get a mixed fraction, but what we want to do first before we do that is to cancel. So we look for a number that can go both into the numerator and denominator. In this case, 2 can divide both of them.
Okay, sir.
So it's really simplifying the fraction by canceling. That's what we do.
Okay, sir.
So as I was saying, looking at this approach, you know, it involves you doing a lot of things. You have to find LCM, you have to add fractions, then you have to move things across, group the unlike terms, and so to me, it is a little bit more tedious to work with, right? So for me, what would be a better approach for me? So I'll show you another approach now. Right? And to me, that's a better approach. But if you feel like this is a better approach, the one that we have here, then whichever one you feel comfortable with, you work with. No problem with that, all right? So which other way we could work this? Now, as I mentioned before, if we get rid of the denominators from in the beginning, it will make our life much easier. Ms. Grissom, you can lower your hand now. All right, now the easiest way to get rid of the denominator here is to multiply the entire fraction, the entire equation. Now we are going to multiply the entire equation by the LCM of all the denominators. Now remember, this 2 here will be 2 over 1. And so if we are to find the LCM of 4, 5, 2, and 1, what would be the LCM? What's the lowest number that all these numbers can go into without a remainder? 20, right? So as I was saying before, we could multiply right through the entire equation by 20. All right, so if I multiply everything by 20, now what would this do? All right, this is how it would work. So we would say 20 times x over 4. All we would do would cancel the 4 with the 20. So 4 into itself goes 1. 4 into 20 goes what?
5, sir.
Right. So we would now take the 5 and times it by the x. So we would just simply have 5x. And at that instance, the denominator, we don't need any more denominator. So we will just have 5x from all of this. So the same thing we do with the next term. So we say 5 into 20 goes 4 times. And so we take 4 times the numerator. So 4 3's give you what?
12, sir.
12, right. And same thing, we go across the other side of the equation, and we do the same thing. 2 into 20 give you what?
10.
10. So we take 10 times 3x give you
30.
30x, right. And so we say 1 into 20 give you what?
20.
And so we say 20 times negative 2 give you
40.
40, right? Now, there we simplify the entire thing by just getting rid of the denominators. So all we need to do now is to solve this equation in the usual way. So if you want, depending on how you want, we generally bring the x's to the left side where we generally do that, but we could bring all the x's to the right side too. So that wouldn't be a problem, right? Now, if we bring all the x's to the right side, being that 30 is larger than 5, it means that when we calculate the x's on the right side, we will get a positive value for x. If we bring all the x's on the left side, we're going to get a negative value for x. Now, it's just another preference there. If you want to bring all the x to the left, you want to bring all the x to the right, no problem. But let me just take a different approach, bring all the x's to the right and all the numbers to the left. So if I bring the 5 over here, 5x over here, and I bring this negative 40 over here, the negative when it goes to the left side becomes positive 40. So we have positive 40 plus 12. And then now, what we now have this positive 5x, when it goes to the right-hand side, it becomes negative 5x. So we get 30 minus 5x, 30x minus 5x. And so the left side now we would have 40 plus 12, which would give you 52. And then now to the right side, we would subtract 5 from 30, and that would give you how much?
25.
25x. And now if we divide both sides by 25, so this will cancel with this. So we have 52 over 25 equal x. Now we can flip around the equation, put the x on this side now, and put what we calculate on the left side and the right side. So this becomes 52 over 25. All right. So you see, we could approach, sorry, it's supposed to be 52 over 25. All right, 52 over 25. If you approach it like this, you find that you have less tasks to do in the steps. When you work it with the fraction, you have to carry out the whole addition of fraction and so on, which really is pointless because you really just only want to solve for x. You don't really want to go through the process of doing fraction if you don't have to. Is that clear, guys? Any question? And whichever method you want to approach it by, it's up to you, but just bear in mind that, you know, you don't want to work hard. You want to work smart, especially when you're doing math and times against you. All right, guys? All right, so with that said, we multiply both sides by 20, we get that. We group the x's on the left side, and so we have that. All right, so here we have some questions. Now I am going to skip this section a little bit because I don't want to spend much time doing these. I think you should be able to do these on your own. All right, so I'm going to ask you to just go to the notes, the class notes, look for equation, and then click on the assignment, and you will see these questions come up. Just spend some time and go through them on your own for practice. All right. Now, in the interest of time, I want to just move along and quickly so that we don't have to spend too much time on these. All right, but all of these, you can take the same approach, getting rid of the denominator by multiplying through by the LCM, just as I did. Now, for this one, for question 27, you could use the same approach, multiply everything by the LCM, or you could probably work out better if you do the cross multiply, right? So if you do the cross multiply, what you would have is 3 times bracket 2m minus 3 on the left side, and on the right side, you would have 4 times bracket 4 minus 5m. All right, if you take that approach, it might save you from trying to do LCM. All right, so this approach, once you have a fraction with expressions in the numerator on the left and right side of the equation, you can do cross multiply. So bear that in mind. All right, guys. So with that said, I just want to jump into inequations, or what we refer to as inequality. Now, for inequality in equation, we don't have a balance. So the left side is not equal to the right side. All right, the left-hand side is not equal to the right-hand side. Now, there are some symbols that we generally will use when we are dealing with equality. So first, let us talk about things to note. Solving an equation is similar to solving an equation, meaning that the same way how you go about solving equation, is the same recipe, the same steps, you do the same thing. The only difference going to come now in the answer, because in the answer now, instead of having, as Ms. Wason was trying to put earlier, a single value, sometimes you may have a range of values that represents the solution. All right. So that's a difference, but you're treating them in the same way as how you treat equation when you're solving. You're making X the subject or making the unknown the subject. All right, so the equality sign is replaced with one of the following signs. So you can have less than, right? You can have greater than. You can have less than or equal to, you can have greater than or equal to. So instead of using an equation, an equal sign, these are the signs you're going to see when you're dealing with inequality. But as I said before, you're following the same rules that you follow when you're solving an equation. So when you're treating with inequality, you just imagine that you're solving an equation and you solve it right down to the answer. But it's only when we are going to talk about the answer now, we will determine what range of values should be satisfied in your answer. Is that clear, guys? Now, one of the things I want to point out quickly, because sometimes students don't really, some students, it depends on the student, don't really have a clear understanding of which sign is less and which one is greater than. Anybody know how to determine which of these symbols is the less than? Suppose you don't get the meaning of them. How do you determine which one of the sign is less than and which one is greater than?
Sorry, the alligator mouth always open to the biggest number.
All right, good. All right, so you can think of it that way. All right. So that's one way. Another way to look at it, if you think of it as an arrow tip, the tip of the arrow, the pointed side always point to the side which is less. All right. And as Ms. Wason said, the alligator mouth opens to the greater side. So if you think of this as alligator mouth, then of course over here would be the mouth, and so the teeth them would be here, right? So this side would open to the greater side, and hence the other side would be the less than side. Now the two signs are basically the same. You can think of it as one sign being flipped around. So when it is pointing this way, it is read as less than, but if you flip it over, now it is referred to as greater than. Now, so what is on the left is what you read the symbol as. So So if you have 3 and you have 4, then we can say 3 is less than 4 because this pointed side points to this less than the value which is less. So you read from left to right. So 3 is less than 4. But now we can say 4 is greater than 3. Right? Anybody have any problem with that? All right, now for the less than or equal to sign. Now, so this one is a combo. It is less than and you have to involve what is equal to as well. But you treat the same alligator mouth or the pointed side in the same way. So you can say it could be written as 3, but you cannot say 3 is less than or equal to 4 because something would be wrong with that. What would be wrong with this? Would 3,
Sir, can you repeat?
I'm just saying that for this one, we cannot write this to be true because it is not true. So what is wrong? Can we write this?
No, sir. That is showing that 3
Sir.
is greater than 4.
But this is saying 3 is less than or equal to 4.
Is that true?
Sorry, false.
Why is it false?
So 3 is not equal to 4.
Exactly. So 3 is not equal to 4. So this statement is really not true. But you may see this 3x is less than or equal to 4. Now there's no problem with this. You follow what I'm saying? Now, if you have 3 is less than or equal to 3, is there any problem with that? Is it true?
Yes, sir.
No, sir.
No, because you say if it's 3 is less or equal to 3.
So 3 is equal to 3. That part is true. But 3 is less than 3.
No,
No,
sir.
sir.
Right. So this something wrong with this too. So what we're saying, when we're using the less than or equal to symbol, we're generally using it in the context of unknown. Right? And so you have to bear that in mind. All right, guys. All right. So with all of that said, let me clear what we have. All right. So here, there's something very important about this that we have to note. Now, we are used to working with positive numbers, which will have no sign attached to it. When there's no plus or minus attached to a number, we take it as being positive. And so that is easy to understand when we're dealing with the less than or equal to. But in terms of dealing with negative numbers, now, this statement, -4 is less than -2, is that true or false? Is that true or false, guys?
Sir, to which one?
To this second statement here, this one. Is this true or false?
True, sir. Go running dog now.
All right, so give me an explanation for your answer, Ms. Wilson. Why is it true?
Sir, -2 is greater than